Hi, today we're going over section 2.1, which is simplifying radical expressions. A radical is another way of saying a root. So a square root, a cube root, a fourth root, fifth root, sixth root, those would all be radicals. Now to simplify radicals, we take out our perfect squares or cubes, or at least this is how we've done it so far up to this point in your math. So we know that the square root of 4, for example, is 2 because we know 2 times 2 gives us 4. If we're giving something like the cube root of 27, we know that that is 3 because we know that 3 times 3 times 3 gives us 27. However, in this course, we will have ones where we can't take the entire thing out. So it may not be a perfect square, might not be a perfect cube. Instead, we'll be able to take part of it out and create what's known as a mixed radical. So with mixed radicals, we end up with a coefficient in front of our radical. And to come up with our mixed radical, what we will do is create a factor tree. And then once we have our factor tree, if it's a square root, we'll look for groups of 2 identical numbers. Or if it's a cube root, groups of 3 identical numbers. Now, if each of these groups, we will take that number and put it in front of our radical as our coefficient. Anything that does not form a group stays inside our radical. So we'll do some examples. So first one, we have the square root of 24. So like I already mentioned, we start by factor treeing 24. 24 is the same as 2 times 12, which is 2 times 6, which is 2 times 3. Now, because it's a square root, we're looking for groups of 2 identical terms. So we have these two 2s, so that moves to the front. And then we have the square root of what's remaining, so 2 times 3. So that gives us 2 root of 6. Next, we have the square root of 96. 96 is the same as 2 times 48, which is 2 times 24, which is 2 times 12, which is 2 times 6, which is 2 times 3. Now, in this case, we have more than one set of pairs. That is fine. Each one will just get moved to the front. Now, when they both move to the front, they will end up getting multiplied together. And then our ones that did not form pairs stay inside our radical. So we have 2 times 2 is 4. Square root of 2 times 3 is 6. So square root of 96 is the same as 4 root of 6. Now, our next one's slightly different because it's a cube root. So instead of looking for sets of 2 identical numbers, like for previous 2 examples, we'll be looking for sets of 3 identical numbers. Other than that, everything is the same. So we'll factor tree 32. So that's the same as 2 times 16, which is the same as 2 times 8, which is 2 times 4, which is 2 times 2. So cube root, so we're looking for groups of 3. So we have 3 2s here. We only have 2 terms left, so we can't group those. So we have 2 cube root of 2 times 2. So that's 2 cube root of 4. Now make sure if you start out with a cube root, the end has a cube root as well. If you forget that, that changes it into a square root, in which case it is no longer correct. Okay, next we have writing as an entire radical. So this is doing the opposite operation. So it's changing from mixed radical into an entire radical. So we need to move a coefficient from the front and move inside. we do it by squaring the coefficient and then multiplying by the number inside. If it's a square root, if it's cube root, then we cube the coefficient and move it inside. So first one, we have 4 root 5. So that would be the same as 4 squared times 5 inside our root. So 4 squared is 16. 16 times 5 is 80. So 4 root 5 is the same as the square root of 80. Next one, we have 3 root 6. That's the same as 3 squared times 6 inside our root. So we have 3 squared is 9 times 6. So 3 root 6 is the same as the square root of 54. Next one's slightly different because it's a cube root. That just means that our coefficient in front will be cubed instead of squared. So we have 2 cubed times 3. 2 cubed is 8. So we have a cube root of 24 is the same as 2 cube root of 3. Now, sometimes we'll deal with variables instead of numbers, but essentially we deal with it the same way. So for example, simplify, we've got x cubed. We can still factor tree that. So that's the same as x times x squared. X squared is the same as x times x. So I have a pair of x's, so I'll have an x move to the front, and then I have an x that stays inside. Next one, I have the square root of x squared, y to the power of 5. So x squared is the same as x times x. So we have a pair of x's, so an x will move to the front. Next, we have y to the power of 5. That's the same as y times y to the 4, which is the same as y times y cubed. Y cubed is y times y squared. Y squared is y times y. So I have 2 pairs of y's to move in front and then one that will stay inside. So I have x times y, square root of this remaining y. Now we can simplify this. We can't combine our x with our y's, but we can combine these two y's. So we've got x, y times y is y squared, square root of y. Next one, we have a mix of numbers and variables. We can still do it the exact same way though. So we'll factor tree 45, that's the same as 5 times 9, which is 3 times 3. So we have a pair of 3's, so we'll have a 3 move out and 5 will stay inside. Next, we have x squared, that's the same as x times x. So we have a pair of x's, so an x will move out front. Next, we have y to the power of 5. That's the same as y times y to the 4. Y to the 4 is the same as y times y cubed. Y cubed is the same as y times y squared. Y squared is y times y. So I've got 2 groups of y's to move out front. For y will stay inside. And then we've got z. We can't break this down, so it's going to stay inside. So we'll write out our coefficients first. So we've got our 3, then an x, then y times y, root of, we've got 5 remaining inside. We also have a y remaining inside and a z remaining inside. So simplifying this gives us 3x y squared, root of 5yz. Okay, so now that we've started dealing with variables, we also have to consider restrictions. If we have a radical with an even index, so for example, a square root, a 4th root, an 8th root, the value inside the radical cannot be negative. This is because if we take any number, multiply it by itself an even amount of times, it will always give us a positive. So therefore, we cannot find terms that would, for example, give us a 4th root of a negative, because something multiplying by itself 4 times will never give you a negative answer. So most of our restrictions are based off of the fact that we cannot have the negative inside the root, which means our lowest possible number inside our root is 0. So we're we're basing our restrictions off of that. So for example, state the domain. The first one we have square root of x. So this one's fairly straightforward. Our domain will simply be x has to be equal or greater than 0 because that prevents us from having a negative inside of here. The next one we have a square root of negative x. So that one will be our domain has to be equal or less than 0 because we want our x to be a negative to cancel with this negative to give us a positive. Now, for this next one, we have the square root of 2x squared. So this one, even though it's a square root, actually has a domain of x is all real numbers. Now, the reason for this is because we have this squared. And essentially any number squared will give us a positive number. So no matter what we put in for this x, we're never going to be able to have a negative in here, which is why it is x is all real numbers. This next one's a cube root. Key thing here is our index is an odd number. So automatically, as long as our index is an odd number, it's x is all real numbers. Now for these next two, we have an extra term in here, which complicates it slightly, but we're still basing it off the fact that what's inside has to be equal or greater than 0. So what I do is look for what x value makes us equal 0. So that would be -2. And then I know that my x has to be larger than -2 to prevent this from being 0. So x has to be equal or greater than -2. Next, we have 3 minus x. So for this one, x, the value if it makes us equal 0 is 3. And we know that if our x is larger than this number, we're going to have a negative. So therefore, x has to be less than 3. Okay, so practice for this section starts on page 95.